Hello everybody, Mr. K here. I'm your host and I'll be instructing you through Unit 3, Day 11, Quadratic Applications, Vertex Form. Okay, so there's a little reminder of what vertex form, one of the four ways it can look. Okay, it either can start with a y, it can start with an x, and that a value can either be positive or negative depending on which way your parabola is facing. Okay, so if you need a quick little runner-up on vertex form, maybe jump back to one of your previous homework lessons to kind of reiterate and help you remember what vertex form is. Okay, and so anyway, vertex form gives you the vertex, right? You got your h and k there, where h and k is the vertex of the parabola. And to put a quadratic into vertex form, we are going to use completing the square. Okay? But we are not solving the equation. Okay? We are only algebraically manipulating one side. Okay? So a little bit lengthy there, but we're not solving the equation. We're only algebraically manipulating one side, and to make sure to get x or y alone before you start. Okay, and so a lot of problems already kind of do that for us. I think only a couple where we have to move things from one side or the other. But it doesn't hurt to discuss why, which letter to pick from, right? Because if you look down here, you're like, well, which ones do we set equal to, right? Or, which one do we leave alone, right? If you look in these two, right, which one's got the exponents? All right, the x's do. Okay, so that's why y is left alone. Again, the x has got that square exponent there, so that guy gets left alone. If you look at number 4, though, the y has the square on it. So as you can see, we got x set equal to itself. All right, so anyway, so it all depends on, which variable doesn't have that extra extra exponent sitting in the corner there, right? It doesn't have that x squared or y squared. Okay. So anyway, use completing the square to put the following quadratic in vertex form. Okay? So we are not going to be setting this equal to 0. Okay? But what we are going to do is we're going to factor out that 3 from that first part of the expression. Now, mind you, I didn't break any rules, okay? I didn't change the value of anything. All I did was factor out that 3. And now I'm ready to complete the square, right? Because when we complete the square, this is what we're looking for. We're looking for the left side of that equation to look something like that, okay? So in order to do that, you take that b value, which is 4, divide it by 2, and square it. And so we get a negative 2, which is squared, gives you a positive 4. And so beforehand, we were adding 4 to both sides. Now we just add that 4 on the inside here, okay? However, all right, in order to do that, okay, we can't just add something to the one side and call it good, right? We have to kind of balance that equation. And the only way we can balance that is if we subtract whatever we just added inside that parenthesis. So because we added a 4, okay, your first guess was like, well, we would just subtract 4, right? But really, okay, it's 3 times 4, okay, because it's inside this parenthesis here. So that 4 is being multiplied by that 3. So we don't want to subtract 4. We actually want to subtract 12. So it's 3 times 4. Whatever this number here and this number is, okay, that's what you multiply together, and that's what we are going to subtract by. All right, and let's make sure that we're all good here, right? So if I factor through, I have 3x squared minus 12x plus 12 minus 5 minus 12. And then what goes away? The 12s, and you're left with what we had before. Okay, so again, not breaking any rules, right? All good. Okay, we're still there. Now, this is where we utilize that perfect square trinomial. And so this becomes x minus 2 squared minus 17. And there is our quadratic in vertex form. Let's take a look at the next one. Next one. Okay, very similar process. We already have the y set by itself, okay? And so I'm going to take out a 4. All right, and again, I didn't change the value of anything, and certainly if I were to distribute that 4, I would get the same expression up top, okay? Again, we're just trying to get it so that we get this by itself so we can utilize that completing the square. So I'm going to go negative 6 divided by 2, which is going to be a negative 3. Negative 3 squared is 9, and so I'm going to go y is equal to 4x squared minus 6x plus 9 plus 8, and then because I added, not technically 9 here, what I really added was 4 times 9, which is 36. So in order to make sure I'm not breaking any rules, I can't just add something to one side of the equation and call it good. All right, I have to actually subtract that number, and so that number is 36. Okay, and again, if you don't believe me, run it through real quick. 4x squared minus 24x plus 36 plus 8 minus 36. 36's go away, and again, we are left with what we started with. So I haven't broken any rules yet. Everything's still hunky-dory. All right, now I'm going to factor this guy. So this is going to be x minus 3 squared, and this is going to be a negative 28. Let's take a look at number 3. Okay, so number 1 and 2, we were just converting it into vertex form. Now we're utilizing our directrix and focus in order to answer these questions here. Okay, so in this one, okay, I got this y minus 4 on the right. I need to get that y by itself, and so I add 4, and so I'm starting with x squared plus 2x plus 4 is equal to y. All right. For whatever reason, I kind of like y on the left, so I'm going to move that over there. All right, I don't like y or variables on the right. It's just a preference. Anyway, okay, so here's what we want for completing the square. So I don't have to factor out anything. All right, I just complete the square, but I'm only utilizing this part of it. Okay, so I'm going to go y is equal to, well, take that b value divided by 2, square it, so you get 1 squared, which is 1. Okay, so I'm going to go x squared plus 2x plus 1, and then whatever I add inside there, minus 1 plus 4. So I don't have anything out in the front, right? I didn't have to factor out anything. I didn't have to factor out GCF. And so, whatever I added in there, right, I would just, well, take it away on the outside in that case, just subtract 1. Okay, so now we have a perfect square trinomial. And so we end up getting x plus 1 squared plus 3. And that is our equation in vertex form. Okay. However, we're still not done here yet. All right. So what we're going to do is we first have to come up with our vertex. Right. So our vertex, based off of our information here, is negative 1, comma 3. Okay. Remember, this is y is equal to ax minus h squared plus k. Remember, they have that negative sign in there. So if you see a plus sign in here, a plus 1, that means our vertex point actually has a negative sign in it, right? Because 2 negatives in a row equal positive, and that's why we're getting that. So anyway, going back to this problem here. Okay, let me draw this guy in. 2, 3, 4, 5. Negative 1, comma 3. All right, and so remember our focus falls on the inside, so in order to do that we must find our p-value. All right, so in order to find the p-value, we must take our a value and set it equal to this formula right here. Okay, this is used to find that p-value. So I cross multiply, 4p is equal to 1, divide by 4, and p is equal to 1/4 or 0.25. All right, so that means our focus is just 0.25 units up from our vertex. So our focus is negative 1 comma 3.25, and then our directrix, which is just going to be a horizontal line underneath it, is going to be y is equal to, I'm going to go down 0.25 from the vertex, so y is equal to a 2.75. Let's take a look at number 4. All right, number 4, now we have an x equals something. All right, so this isn't going to be facing up or down, it's actually going to be facing left or right. Okay, so process is still the same. Okay, I'm going to complete the square with this guy right here, so I'm going to go negative 6 divided by 2, which is negative 3 squared, which is 9. All right, did I do that right? Yes. Groovy. Okay, so here we go, y squared minus 6y, okay, plus 9, and then on the outside, minus 9, right? Can't just add 9 in there, but certainly can if these things just cancel out, right? So still not breaking any rules. However, why I'm utilizing that is so that I can get my perfect square trinomial right here. So y minus 3 squared minus 2, okay? Now remember, whoops, vertex form, when you have an x that's starting, okay, things get switched around a little bit. So it's y minus k squared plus h. So remember the h's go with the x's, y's go with the k's. Okay, so in this case, our vertex point is going to be a 3, comma, negative 2. So let's draw that in. Okay, and so we're going to be facing to the right. Okay, and again, we just have that a value of 1, so I know my p value is just going to be a 0.25, but instead of moving up and down the y-axis, we're moving left and right along the x-axis, and so our focus is going to be, I'm going to move to the right, so it's going to be somewhere, let me get a different color, somewhere here, so it's going to be, where's my point? Oh, I'm sorry. 3, right, because we're not changing our height, but we're going to the left a little bit, so it's going to be a negative 1.75. So our focus, and then our directrix, oops, not, it's a parenthesis, it's going to be a vertical line just behind our vertex here, and it's going to be x is equal to a negative 2.25. Okay, last one. Somebody's throwing stones, right? Don't be throwing stones next to windows, just giving you some advice. So a stone is thrown with an upward velocity of 14 meters per second from a cliff 30 meters high. Use the given equation to answer the questions below. Here's our equation where v naught represents the initial velocity and h naught represents the initial height. Okay, so unfortunately for us, we just have to fill in some blanks here, right? And so our equation looks like this: negative 4 point, and I'm going to actually change that to a, I'm just going to change it to a y. Okay. Oops, 4.9 t squared plus 14t plus 30. Okay, so you guys are probably thinking, Mr. Kaya, there's a decimal there. Okay, we can still pull out a GCF from there. I'm going to pull out a 4.9. All right, so that leaves t squared by itself. Okay, but what does that mean for the 14? Well, when I take out a negative number, this is going to become negative, and this just becomes 4.9 on the bottom plus 30. Now, just think about this. If I multiply this through, would I get the same thing above? Absolutely. Okay, and so that's what it means to factor something out. You're taking that number and you're actually dividing it by that GCF, okay? So we're all good. Oops, forgot a T there. Okay, so let's finish this problem out and call it a DAY. All right, so we've got to take our B value, which is 14 divided by, or negative 14 divided by 4.9. So I'm going to leave this all together. So this is going to get divided by 2 and then squared. Okay, so let's figure out what that is inside parentheses first. So I'm going to go, whoops, negative 14, oops, in parentheses. Negative 14 divided by 4.9. All of that divided by 2 gives me a negative 10 over 7, and negative 10 over 7 squared. Sorry, excuse me. It's going to give me 100 over 49. Okay, and so that is what I have to add to both sides. So negative 4.9 t squared minus 14 over 4.9 t plus 100 over 449, okay, plus 30. Now, in the past, right, we've just been subtracting whatever we add in the middle, all right? But if you take a look, we have a negative 4.9. So when I multiply this through, this number over here actually becomes a negative number, right? So let's do that. So negative 4.9, I'm going to multiply that by 100 divided by 49. What do you get? You end up getting a negative 10, right? And so I don't want to subtract 10.
Deborah Winkleman to the main office, please. Deborah Winkleman to the main office.
Oh boy. Well, I don't want to, right? I don't want to subtract 10 because then I would just end up with a negative 20. So I actually want to add 10 this time. So this one was a little bit tricky in the sense that this number right here times this ends up becoming a negative 10, right? And so to compensate for that, we must add 10, and so that we didn't break any rules. All right, so finally, we are ready to rock and roll. All right, so y is equal to negative 4.9. Well, this right here is just going to be whatever this value is right there. So it's going to be t minus 10 divided by 7 squared. All right. And then plus 40. So, can we answer these questions? Sure can. What is the highest height the stone reaches? Well, this is our vertex here, right? And this is our y value. So that's got to be 40. And we're talking meters. And at what time does this happen? Well, what's negative 10 divided by, oh, I'm sorry, not negative 10, just 10 divided by 7. Well, that is 1.428 seconds. Okay, so hopefully this video helps you out a little bit. If you're quarantined, I am sorry, and I apologize for the length. This is probably about 20 minutes. So good luck, okay? And yeah, good luck. Any questions, always feel free to ask me. Thank you.